Hi guys, this is Amirtha. I hope everybody is safe and healthy at home right now. Today I wanted to go over target mode gameplay for Checkpoint 4. So in Checkpoint 4 we have an abstract class called game, and we have two subclasses called target game and area game. And so both of these subclasses define and control the logic and design for a target mode game or an area mode game. So today we're going to go over how to implement the target game class, which controls target mode games. First thing we have is a constructor. Keep in mind that this is already written for you, but I thought going over it would be helpful because it goes over, it initializes two hash maps that we will be using throughout the target game. So in the constructor, we're given a JSON object called full state. And so full state has multiple different pieces. For example, you can see it has a type called full, so that's how we denote that it is a full JSON object that holds all of the data for a target game. And there's different things like the proximity threshold, which will come in handy for when we're trying to claim targets. There's a players array that stores the information of every player as well as their paths. And this should also include the current user as well. And we also have a JSON array called targets. And this stores every target that has been placed on the map, both captured and uncaptured. For example, this target has been captured. Its team ID is 2, but this target has not been captured. As you can see, its team ID is 0, or observer ID. So, using that full state, we initialize a map called targets, and this just maps a target ID to a target instance. And if you remember the target class from Checkpoint 3, that's what we're using here. And the target IDs are given in the full state. We also declare a hash map called player path. This is really important because we will be using this to claim targets. But the player path is designed with the keys being players' emails, and the values being a list of all the target IDs that represent the targets that they've captured. So basically, for example, we have a key called player1@illinois.edu. So this is just some player, and this is their email. And the value that it points to is a list of target IDs, T11, T12, and so on. So this represents every target that they've captured, basically the path. And so we use this in a helper function for location updated called try_claim_target. So try_claim_target will use the snake rule to determine if we can capture a target. So in this example, we're on blue team and we're trying to capture this target. This is purple, so it hasn't been captured yet because it has the observer ID. And so it doesn't violate the snake rule with our own path. But since this is a multiplayer game, we also have to check and make sure that we're not crossing paths with other players. So let's say one of our opponents is red team. Well, you see here that, with their path, we're actually crossing one of their lines. And so we actually can't capture this target. But say we can capture this target. So we've checked the snake rule with ourselves and with every other team, and we're able to capture this target, right? Then in that case, we want to send a target visit update. So this means creating a JSON object and sending it back. So we have we have this JSON object, and we want to format it like this. If you don't format it in this way, then you will run into errors and you won't pass the tests. But when you don't violate the snake rule, you'll create this JSON object and you'll send that message back. And it has to have of type target visit. So going back to location updated, this is the general function that try claim target will be used for. So for every target within range of the player's current location, we're going to try to claim every single target. So that's pretty much location updated. It's really straightforward. The next function that we're going to be writing is called handle message. So handle message receives data from the server and updates our own targets map and player paths map based on what's been sent to us. So the abstract class game also handles messages. And if it doesn't properly, if it's not able to handle the specific message and it's of type player target visit, then we have to, in the target game class, handle the message ourselves. So an example of player target visit looks like this. So it has a type, so you want to make sure that it is of type player target visit, and it'll be given an email, so the person who captured this target, the team that they're on, and the target that they captured. So we want to update the target's team ID. We also want to extend the player's path so that it holds this target. And if the message is of another type or is invalid, then we don't want to do anything. That's kind of the gist of handle message. Finally, we have a function called getTeamScore. So I put together all these targets just as an example of a map that users could be playing on. And so we have targets of different colors because some targets have been captured and some haven't. So getTeamScore should return these values for the teams. So if we're on blue team, then we've captured 5 targets. And there are 4 uncaptured targets. And you can tell they're uncaptured because they're purple, which is the observer ID. So that's getTeamScore. Also pretty straightforward. But if anyone has any questions about target game, please feel free to post on the help group. We're all here to help you out. And best of luck with target game.